Hey guys, welcome to lesson 9. This is just a revisit of scatterplots, and we're going to go back and use that linear regression piece that I talked to you guys about in lesson 8. I'm going to show you how to actually use it this time. The essential question, how do I use linear regression to interpret scatterplots? Basically, we just want to be able to make much more accurate statements about scatterplots than you did in 6th, 7th grade whenever you first learned about them. All scatterplots have some sort of correlation to them. You'll see over here they could have a positive correlation. That's just when everything is increasing. The x numbers are increasing, the y coordinates are increasing, everything's going up. You might also have a negative correlation. That's when your x amount, your x coordinates are increasing, but your y's are coming down. So everything is kind of flipped around backwards from the positive correlation, basically. No correlation is essentially just when it looks like somebody threw up a bunch of random coordinates all over the scatter plot. They're just everywhere. You can't really tell if they're going up or going down or just going side to side. They're just all over the place. So the question here down on this green stuff right there is asking, actually it's not asking, is it? It's simply just telling you that this scatter plot has a positive correlation, which makes sense because the x's, the x coordinates are all getting bigger right here, and the y coordinates are all getting bigger as well. Okay, that makes sense because we go from 82 to a little over 75, and as I go further down, I get to 88 up to 450. They're getting bigger and bigger. You could also draw that line of best fit through there and see that the slope of it is increasing. So it has a positive correlation. Remember to pause and go and copy all that information down if I'm running too fast, since I already wrote this stuff down. Second scatter plot down here, we've got a question right down here that I asked you about it. Okay, how much money is made when the temperature is 21 degrees Celsius? Well, normally you would come up here and you would look on your table or on your scatter plot and you go, okay, 21 degrees is right there, and so you would read up to the graph and you'd say, oh, well, this is how much money is made right here. The only problem is there's no data point right there to give us that information. You could make a pretty darn good estimate. If it was a multiple choice test, you'd probably figure it out. What I want to show you, though, is how to use your calculator to input all of these data points that you are given so that you can write a very accurate function, an equation, and then you can answer this question just as exactly as is possible based on the information we're given. Take a minute and jot down all of these values down here. I just made a T-chart. I had to break it into two parts because I ran out of room. But I created a T-chart just based on the data points in the table. Okay, so the first one is I went over about 11.9 and up to right there, which I said was about 190. Okay, if you and a partner were doing this, you might disagree on the exact numbers. We're having to make estimations. So pause me right now, jot down that table of values, and then when you come back, we're going to go right here into our calculator, which I know you don't have with you, so you're just going to have to watch. And we're going to go through the process of entering stat, edit, and putting all that stuff in there. If you jump back over here, that is this information that I'm referring to right there. Pause and jot that down. You already wrote it in your last set of notes, but it never hurts to write it again. These steps right here are the exact steps you're going to need for your calculator, which again is different than the one that I'm going to show you because, hey, that's just how technology rolls, right? Couldn't be simple. I'm going to jot those down, and if you had a calculator, you would do this. You would hit the stat button because that's what it says to do first. Then you would arrow over to calc, and then that's a lie. Wow. This class doesn't know what she's talking about today. Sorry. Let's try that again. It says to do stat edits. If I read my own directions, this would be better, right? Stat edit. So I hit stat, enter for edit, and it brings up L1 and L2. What this step right here wants you to do is to enter the X and the Y. X is L1 and Y is L2. Okay, so if I enter in all that information, I'm not going to enter all of them because it's going to take forever. When it's your turn to do this, if we were really going to answer this problem, you would have to do all the points. Otherwise, you get inaccurate data or inaccurate answers. So pretend like I'm entering everything. Okay, I only went to 17. Again, if this was you doing this on your paper or on a test, you would have to enter all of them. I'm just trying to save us a little time. So I did stat edit L1 and L2. Now I'm supposed to hit stat calc 4 to move on to the next part. So straight from the screen, stat, now arrow over to calc. Hit the number 4. You'll see right in the middle it says linreg, that's linear regression. Now on my calculator, I'm going to hit bars, y-vars, enter, enter, enter to make it work. You'll notice on yours over here, look back to the right, you have to do this extra little step right here because you have a newer operating system on your calculator. So you have to, and I'll show you what it looks like when you get here. It's not a big deal, but you're going to hit enter 3 times before you hit vars, y-vars, and then enter through to the end. Essentially what this has done for us is if you look back on my calculator, it gives you a linear equation, ax plus b, that's just mx plus b, don't ask me why they use a, and you would fill in the numbers. So my equation, if I go to y equals, looks all crazy, but it's not. It's just 48x, all right, 48x plus a negative 411, right? So we don't even really care about that because I can go to the table now and answer my question. It asked me, come back over here, how much money is made, so what's the y value when the temperature or the x value is 21? I already know in my head it's going to be somewhere in here. So all I have to do is come back to my table and scroll to the appropriate x value, pick up the amount of money that we've made, and there's the answer to my question. Now I'm not going to actually do that right now because I told you I don't have accurate data entered in my calculator because I didn't put it all in. We'll do this in class together, but I just wanted you to have the information before you got here. Check it out. Last one. Here we have a negative correlation because it tells us that, right? Check it out. The y's are decreasing as the x's get bigger. So if I drew one line through all those points, it looks something like that. Remember, linear regression is the calculator method that gives us the exact line through those points, like the most accurate, best line possible. So what you would do now is go back to your calculator, and you would run through the stat edit process again to enter in all of these points. I pulled them straight off of the graph. Over 1, up 7, that's where I got the first point. Over 1, up 8, that's where I got the second point, and so on. So that's where all the information comes from. Pause me now and write all this stuff down. Then you could write down this question, which we will answer when you get to class. What is the value of y when x is 2.5? That's all there is to this. You're getting lucky, and we're not going to go through this one on the notes because the bell is about to ring and I have a class coming in. So we'll finish this up when you get to class on Monday or Tuesday. And don't forget your questions and your summary. See you later. Have a good weekend.